Welcome back. Today we're going to do something a little different. We are popping the hood on modern AI. We're going to deconstruct how these incredible systems are actually built, piece by piece, from just a raw engine all the way to a fully autonomous agent. All right, let's get into it.
So we all use AI, right? But have you ever really stopped to wonder what's actually going on in there? It's not magic, and it's definitely not just one single thing. It's actually a series of brilliant engineering layers, each one solving a specific problem. And today, we're going to build one together, layer by layer, right from the ground up.
Every great machine starts with a great engine. And for AI, that engine is an absolute powerhouse of language and reasoning. This is our foundation. This is where all that raw potential comes from.
So at the very heart of all of this is the large language model, or what we call an LLM. The best way to think of it is like a brain. But instead of biology, it's a massive, massive neural network. It's been trained on just a mind-boggling amount of text from the internet, from books, you name it. And that's what allows it to learn the patterns, the grammar, and even the subtle nuances of human language.
And this right here, these are the two magic ingredients that make it all possible. First, you need just vast amounts of diverse data. We're talking a library of pretty much everything ever written. And second, you need massive computing power to actually process it all. It's that sheer scale that lets the model go beyond just, predicting the next word and start performing really complex multi-step reasoning.
Okay, so we've got our raw engine. But an engine without a steering wheel is, well, it's pretty useless, right? So the very next step for an engineer is to add a control panel, a way to actually steer the LLM's output and fine-tune its behavior for specific jobs.
And this is a perfect way to picture that control panel. These are called generation parameters, and they really are like dials you can turn to shape what the AI says. You can control its length or tell it not to repeat itself. But look at that second one down, temperature. This is one of the most important dials for controlling the AI's, its personality. So, let's see how this one little dial works. If you crank the temperature way down, the AI becomes super focused, very deterministic. It's going to stick to the most likely factual answers. This is perfect for, say, a customer service bot. But if you crank the temperature way up, the AI becomes this creative partner. It starts exploring less common word choices, making it fantastic for brainstorming ideas or even writing a poem. One dial, two completely different personalities. But then, what happens when creativity is the last thing you want? Think about tasks like pulling data from an invoice or running an automated workflow. You can't have the AI getting creative there. You need the exact same output format every single time without a single failure.
Well, this is where we switch from just talking to the AI in conversational English to speaking its native language, structured data. By using a format like JSON, which is really just a predictable, machine-readable way to organize information, an engineer can give the AI a super strict template to follow. There's just no room for interpretation, and that means the output is predictable, it's consistent, and it's ready to be plugged directly into other software.
Okay, so our AI now has a powerful engine and a really precise control panel. But we have a big problem. Its knowledge is completely stuck in the past. To make it truly useful, we need to give it a major upgrade.
And here's the issue. An LLM's training data has a cutoff date. It knows absolutely nothing about events that happened after it was trained, and it definitely doesn't know anything about your private, internal company documents. So, how do we fix this?
The solution is this really clever technique called Retrieval Augmented Generation, or just RAG for short. The easiest way to think about it is like giving the AI an open book test. Before it answers your question, it does a super fast search in an external database, one that's filled with today's news or your company's latest reports, and it pulls out the most relevant info. It then uses that fresh context to generate a current and totally accurate answer. Pretty smart.
All right, so RAG is fantastic for updating the AI's knowledge, for giving it new facts. But what if you need to teach it a completely new skill? For example, how to write code in a very specific proprietary style for your company, or how to adopt the personality of a specific character for a game. That's not just about facts, that's about changing the engine's core behavior.
Now, the old way of doing this was called fine-tuning, but for these modern, massive models, it's a total nightmare. As you can see here, you'd have to create a full copy of the entire multi-billion parameter model for every single user or task. The storage costs would be absolutely astronomical. It's just completely impractical to scale.
Thankfully, engineers came up with a much, much smarter solution called LoRa. Instead of copying the whole engine,
LoRa freezes the original massive model and just adds a tiny new layer of trainable parameters right on top. It's kind of like a small software patch or a little plugin. You get all the benefits of customization without the insane cost and complexity. It's just incredibly efficient.
So, we now have it all. A powerful engine, precise controls, and a super efficient way to upgrade its knowledge and skills. It's finally time. Time to assemble all these components into the final product, an autonomous system that can think and act all on its own.
And that brings us to the AI agent. An agent is a system that uses the LLM we've just built as its brain. It can understand a goal, break it down into steps, use tools, and actually execute a plan to achieve that goal, all without needing step-by-step human guidance.
Now, to build an agent that's actually effective, engineers rely on a toolbox of these key components. They'll give it a specific role to shape its expertise and a really narrow focus to keep it from making mistakes. They'll give it access to tools like software APIs so it can actually do things in the real world. They can even have multiple agents cooperate on a complex problem. And crucially, they add guardrails to keep it on track and a memory so it can learn from conversations with you.
Let's just take role-playing for a second. It sounds simple, but it's an incredibly powerful idea. If you just ask a generic AI to write some code, you'll get a pretty generic answer. But if you tell it, you are a senior developer with 10 years of experience in Python, wow, the quality of its output just skyrockets. That specific persona shapes its entire reasoning process.
And finally, memory. This might be the most important piece of the entire puzzle. You see, without memory, every single time you talk to the agent, it's starting from a completely blank slate. It's like having a conversation with someone with no short-term memory at all. But by giving it memory, the agent becomes context-aware. It remembers what you've talked about, it learns your preferences, and it transforms from just a simple tool into a true collaborator.
So, there you have it. From a raw language model all the way to a sophisticated autonomous agent. We've gone layer by layer to engineer an AI that can reason, learn, and act. We've basically engineered the mind of the machine. The only real question left is, what are we going to ask it to do next?